So Martin is prepared. Okay, I'm sleeping in my chair. Okay, let's hear more. Go.
Okay. Thank you very much. Hi everyone. Thanks for coming to the session. Lots of really interesting things going on here at this event, so really pleased to see you here today. I want to do two things in this session. I am going to talk about the smart home and what that perhaps really means, and what Bluetooth's role is in the smart home. But I also want to kind of change gear and look at Bluetooth technology from a developer's point of view, look at some of the concepts and the things you need to know to be able to use it in applications and devices. Now, you already know that blah, 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 there will be lots of devices soon connected to the internet. So I'm not going to do this again. You've heard this a million times. But there are going to be lots of devices. You already know this. That's me. I like to cycle. And when I cycle and I'm on my bike for hours, I do a bit of daydreaming. And not surprisingly, I think about Bluetooth. I don't think about work all the time, okay? I think about other stuff. But I do think about work some of the time. So I think about Bluetooth. Who knows about Bluetooth Low Energy, first of all? Who's heard of Bluetooth Low Energy? Almost everyone. For those that haven't, there are two types of Bluetooth now. One we call Bluetooth Classic, great for audio, headsets, that kind of thing. The other one, Bluetooth Low Energy, is newer, 5 years old, thereabouts, designed for the Internet of Things, uses very little power, and that's important. Think about the Internet of Things, it's the most fascinating thing to have happened ever, I think. I like to exaggerate. And I think about smart home, because I started getting involved with smart home events and having to talk about it, and I was a bit confused by the word smart and what it really meant, because different people seem to use it in different ways. And I did conclude that there were, well, some smart homes that were smarter than other smart homes, okay? Yeah, slightly dumb smart homes and really clever smart homes. So there seemed to be a kind of spectrum or continuum, and at one end of that spectrum, the smart home, it really just had gadgets that I could control wirelessly, maybe from my phone. So I have some light bulbs in my house, I can turn them on and off and change their colours. Or it was about monitoring things, again, probably involving your smartphone. I have a plant in my house. It is alive solely due to Bluetooth technology. I have a very bad track record looking after plants. They always die very quickly. This one is alive. To this day, 2 years old now, thanks to a Bluetooth plant monitor. But this is the simple end of smart home. These are just gadgets that add some convenience to my life. At the other end of the spectrum, though, we have homes that are essentially self-aware. And they're self-aware because they know an awful lot about themselves. They know who's in the home. They know how secure the home is. They know how energy efficient the home is, for example. And they provide ways in which you can control the systems in the house manually, directly, or through automation. And it's interesting to consider how such smartness can be achieved. What are the kind of key ingredients? One of the primary ingredients to achieving a truly smart home is sensor networks, because it all starts with data. The truly smart home will have sensors all over the home, and when I say all over, I mean outside and inside, in every room, inside the walls, under the floors, in the attic, and outside under the ground as well. And as a consequence, with the right software in the right kinds of devices, the home will know an awful lot about itself at a point in time, but it will also know about historical behaviours, so it can identify patterns and detect anomalies. Security alerts can be generated because things don't look right. So the application of intelligent algorithms to all this data collected by all these sensors, we've heard the word sensors lots of times this afternoon, I was delighted to see. But it can't be done without sensors. And this is where Bluetooth Low Energy comes in. Because if I, as I assert, sensors are critical to having truly smart environments, whether it's home, building or city, then power becomes a primary concern for engineers. We can't populate our smart homes with 100, 150 sensors. If we need to change the batteries every 3 days, clearly that's not going to work. In some scenarios, think about industry, for example, these devices, these sensors will be placed in unsafe environments as well. We can't be entering those environments every 2 days just to change the batteries. So, it becomes a critical factor that these devices can run off batteries for a really long period of time. I'm talking 8 years, for example. Or better still, they don't use batteries at all. So there's a kind of field called energy harvesting, and energy harvesting is about generating power from naturally occurring phenomena in the environment. It might be ambient temperature changes, it might be motion or vibration, or it might be electromagnetic radiation coming through the air, which is all around us all the time. You can generate low amounts of power from these sources, so you don't need batteries, provided the device you're trying to power itself does not need a lot of power. So, devices and their power utilization becomes a factor of all their components and ingredients, and consequently, for communications purposes, you have to have the most efficient wireless communications technology that there is. And to my knowledge, based on all the independent kind of lab research I've ever read, that's Bluetooth Low Energy. So we have our sensor network. We don't need to change batteries every 5 minutes. We can collect data. With the right software now, we can have a truly smart home. And by the way, Gartner, the research group, they state, I think this was the end of 2014, that the average home will have 500 connected devices in it. So add up your tablets, your smartphones, your games consoles, your TVs, your white appliances, all the sensors that are in the home. It really adds up, and there will be hundreds of devices in the smart home. So what other factors should we be concerned about? Well, there are a range of, there's a joke there, range, you see, that's my second word, a range of things to consider. One of them is reliability. I'll talk about that first. Obviously, consumers, they want things to just work. In the commercial world as well, people want things to just work. People don't like things that don't just work. So let's start there. Standards are a constituent part of reliability, because standards are how things should work together, right? That's one of the most fundamental purposes of having standards. It's about interoperability. So I work for the Bluetooth Special Interest Group. We're the standards body for Bluetooth technology. We live and breathe the idea of interoperability and things just working together. There are other standards bodies out there. The true value of a standard is really how many people or how many organisations support it at the end of the day. So a standard for something to do with IoT that 3 companies support is clearly not as valuable as one supported by 30,000. It's not just about standards though, it's about engineering. And with 500 devices in our smart home of the near future, you have to be concerned about how wireless communications is going to be effective in what will be a very noisy environment, lots of communication going on. Some of the low-power wireless communications technologies, there are others, they use a single frequency to communicate on. That's simply not scalable. Stands to reason, it's obvious engineering logic, it's not scalable. Bluetooth works differently. It's designed to work in noisy, busy radio environments, and it uses something called adaptive frequency hopping. So instead of devices working on one frequency and interfering with each other, because there are 500 of them all fighting to use the same frequency, the devices have a little talk and they agree what they're going to do, and they hop around the frequency spectrum and they avoid interference in that way. It's the kind of thing that happens in military communications on the battlefield, I believe. Some interesting misconceptions about Bluetooth and range. Range, of course, is an issue if you want to cover the whole home and the outside of the home. I'll tell you now that if you're a consumer electronics company and you want to equip your product with Bluetooth low energy capabilities, you're going to buy a component called a module from an electronics company who makes them, and that will be part of your product. There are modules on the market today that have a range which is in the order of hundreds of meters, 400 or 500 meters are claimed by some of the module manufacturers, and they publish their test results. So that's way more than most people think. The next version of Bluetooth will be Bluetooth version 5. 4.2 is the version of the spec today. Version 5 will be out at the end of this year. And one of the key changes there is that the range will quadruple without impacting power consumption. We're very careful about the power consumption capabilities of Bluetooth. So 4 times the range, we're into kilometres, over a kilometre now. If you were here this morning in the panel discussion you'll hear I mentioned mesh networks. Mesh networks really matter for all sorts of IoT use cases. When we have very large collections of devices such as sensors that need to communicate data across a broad sort of area, again imagine large commercial buildings, never mind the smart home, think of an airport, then one of the ways in which range and reliability can be accomplished is through using a mesh network topology. And in a mesh network, each individual member of the network can communicate with any other member of the network, no matter how far away it is, provided it can find a path by relaying messages from one to the other. And typically they work in a fairly simple way. There's no routing algorithms. They kind of ripple messages across the entire mesh. But huge range can be accomplished like that. Mesh networks are possible with Bluetooth today, but using proprietary implementations. There's a standards-based specification for mesh networks on Bluetooth coming at the end of this year too. I think I've mentioned ultra-low power already. I don't know if I have another slide on this, I've forgotten, hang on. Some other things to talk about really briefly, because I want to move on to the more technical side of things. Security matters. We all know security matters. We talk about it all the time, and we read about it all the time when it goes wrong. Bluetooth provides manufacturers with effectively a toolkit of security capabilities that they pick from to use in their product to meet their security requirements. So manufacturers are responsible for thinking about risks and the value of data and the use cases, and then decide what their response to those risks are. So you can encrypt data, you can use digital signatures for data integrity, there's a privacy mechanism that stops people being tracked using the device address, it obfuscates the addresses, and so on. Critically, who's heard of FIPS, F-I-P-S? Anyone heard of FIPS? A few of you. So this is the Federal Information Processing Standards. It's a US government specification of security requirements for government departments. If you don't meet their list of requirements, you can't supply into the US government. So it's very tough, very stringent. Bluetooth Low Energy devices can be FIPS compliant as of version 4.2. So we satisfy the most stringent regime around there. Internet connectivity. I'm talking about the Internet of Things in the context of the smart home after all. This requires a gateway. Bluetooth is Bluetooth, Internet is IP. Different ways in which Bluetooth and IP can work together. You can actually run low power IP over the top of Bluetooth because we did some work with the IETF to define how that would happen. But in most cases, a home will be equipped with a gateway of some sort, so it will understand both Bluetooth and IP. And we have standardized a RESTful interface to a gateway, so you use HTTP to drive operations, to discover Bluetooth devices in the home, to connect to them, to interact with them, and so on. So there we go, we have a kind of notification there. We've been reassured that we have closed all the doors and windows. We didn't leave them unlocked when we went on holiday, because we have sensors on the doors and windows. The other thing we have is we have a thing called the HTTP proxy service, and this switches things around. So the gateway is, in that previous scenario, was there to be queried from outside the home, but we can use the HTTP proxy service from inside the home, and it allows Bluetooth devices to formulate HTTP requests with a payload and ask the gateway to execute them. So you can imagine simple things like security sensors on doors and windows that can post something whenever the status changes. I've been unlocked, I'm open now. Or temperature sensors that report current temperature readings every half an hour or every time they change, to a cloud-based home economics analysis service or something like this. So huge amounts of data collected from the home, analysed in the cloud. You get told how to save some money. So those are two ways of linking Bluetooth devices to the internet. Now, I want to move on to talk about the technical side. And I'm going to assume that this is new to all of you, which might not be the case. Let's see how this goes. What I'll do first, I think, though, is I'll show you a couple of things, because I mentioned two broad use cases, controlling things and monitoring things. And I've got a couple of devices that took me forever to set up here, and I'm going to show you for like 3 seconds now. So, On stage here I've got a lighting device which has an Arduino. So the top of the, this is Lego and glue and sticky tape. It's quality engineering, okay? And a battery that sometimes gets disconnected and goes wrong. But it's a light basically, and I have, I don't know if this is connected, let's try this, hang on, there we go. So I've got a smartphone application running on an Android device. And using the menu, I can send effectively commands to the light that tell it to execute certain predefined patterns. Does that look nice? Does it look pretty? I need to know that it looks pretty. Let's try rainbow, that's a good one. There we go, isn't that nice? So that's controlling things. So clearly I can implement firmware, software on small devices that will respond to certain types of Bluetooth message. And we'll talk about what those messages are in more technical detail in a moment. Talked about monitoring things as well. So I've got another thing here. I've got loads of things actually, loads and loads. So I showed this morning, but you probably couldn't see it. This is BBC Microbit. We just gave 1 million of these to 11 and 12-year-old school children in the UK because a report came into our government a few years ago that said the UK is falling behind. All this young generation, they know how to use technology, they're never off their phones and tablets, but they don't know how to code, and they don't know how to make things. So that was a big concern. The BBC, our broadcasting company, they have a remit that's about education as well as kind of media type stuff, so they picked up this problem, and the response was to try and solve it by designing this device with some partners. I was involved in this on the Bluetooth side. It's a microcontroller unit, it's got a Bluetooth low energy interface. It's programmable with lots of different tools. It's basically fantastic. So, I've got an application here that I wrote. So, what we're doing here, I hope you can see things. It's not very good quality actually, I do apologise for that. Let's try moving that to there. Yeah, you can just see that. So I just hit a button that said scan, so it's discovered my microbit. I'm connecting to it now. I've got a menu. You can't really see the microbit, which is a shame. So what I'll do is just select this one. Inside here we've got an accelerometer. If I start moving my physical microbit, you can see that motion of the microbits is being picked up in real time. Every 20 milliseconds, it's very fast, very low latency by the microbit. Lots of things I can do. It has various sensors in it. I've got buttons that do absolutely brilliant things. There's no sound on this, I really wish there was, because I want to show you this exceptional Internet of Things application here. If I press the left button on the microbit, see, cat becomes a tiger, kitten. If I press the right button, it's for kids, come on. We get a puppy, there you go. And that was a wolf. So, controlling things and monitoring things. That's what it's all about. So what I'll do now is drop into the theory and kind of explain what's going on in there a little bit. I'm going to have to talk quite quickly, I think, but anyway. So, Bluetooth is a protocol stack, okay? You all know that, I'm sure. Lots of layers to it. Core specification is 3,000 pages long. You do not need to read it unless you really, really, really want to. It's like the Game of Thrones of the technical world, okay? Nah, it's not that good. But the areas that it's worth knowing a bit about and understanding the terminology are called GAP, GATT, and ATT. So GAP is the generic access profile. It's to do with discovery of devices. GATT is the generic attribute profile. It's about the structure of state data that a device has. And the attribute protocol, ATT, that's how they talk to each other. Let's talk about device discovery, first of all. Don't know if this will work, but what the hell. So, first of all, two devices, before they can talk to each other and do anything, they need to find each other. And this is where this thing called GAP comes in. Now, GAP makes use of a capability called advertising. Two devices will have two different roles. One device will be advertising, so it's transmitting small packets of data periodically, maybe every 100 milliseconds, saying, I'm here, I'm here, I'm here, and maybe some information about what the device is. Another device, maybe a smartphone, will be scanning, looking for devices that look suitable to connect to. And I would imagine that if I press this button here that says start scanning, oh look, they're all advertising packets. And there are lots of them. So there's lots of Bluetooth stuff going on in this room right now. If I was to slow down and look at it, we could find out a bit more about what those devices are, but we don't have time. And we have plenty of other hexadecimal to read in our own time. So, advertising is fundamental to devices getting discovered. Scanning is how other devices go about finding devices to play with. Now, in the world of Android, who here is an Android developer? Done any Android development at all? Ooh, not many of you. Oh, very few. Very interesting. Okay, I'm using Android as my example, but don't worry, because it's the concepts that matter, not the APIs. Bluetooth Low Energy is on like 96% of all smartphones, so it's on all the platforms, and there are native APIs for Java, C, C++, whatever, Swift, and there are various web-based SDKs as well, so you can use JavaScript, Apache Cordova, PhoneGap, stuff like that. So, whatever your skill set, understand the concepts, and then applying them in your programming language on your platform is a piece of cake. So, Android's pretty good though. It provides us with lots of really nice classes that are very logical to use, and those are the ones that are involved in the discovery process. You can see I've got a scanner, Bluetooth LE scanner. I can create filters that make sure I'm not bothered about devices I'm not interested in, and so on. Code tends to look like this. So I'm creating scanner objects here, and eventually at the very bottom, you probably can't see at the back, it says start scan. You'll never guess what that does. Oh, God, sorry. I really hate this device. What have I done? Oh, there we go. Right. Blame the device. It wasn't me. Oh, yeah, so I missed a slide there. Just go back a bit. Yeah, so having started the scan process, I get callbacks to a method that say, here's a device that you might be interested, here's a device you might be interested in. So that pattern is generally how it works regardless of the programming language that you're using. A lot of what goes on is asynchronous. So you kind of kick things off, you provide some kind of callback function or method, you get a callback with some data or an object in it that you'll then use, and that is generally applicable. Press button carefully. There we go. So, discovery. Once you've discovered some devices, often on a smartphone, you're going to present a list to the user. You know, maybe it's an application that works with heart rate monitors for people who like go running or something. Maybe you discover lots of them because, you know, they're at a race and they have to go, yeah, that one's mine. And probably you'll put the one that's nearest using signal strength at the top of the list. Once they select a device, you're going to connect to it. And once we're connected, we can start interacting and doing stuff of interest. So Android again has some nice classes. Bluetooth device, of course, is a device discovered by Bluetooth. And we have this thing called Bluetooth Gap, which is like a controller that I can use to initiate all sorts of different operations. It's the place I go to for almost everything. And the callback class there, I kind of subclass, and that's where I get all my callbacks. Did I go backwards then? Yeah, okay. Yeah, so during the scanning process, I've been given one of these Bluetooth device objects, and what I'm going to do is extend a class called Bluetooth Gap Callback, and you can see here it's got a on-connection state change. So basically, once I initiate the connection process, I'll get a callback that says you've connected. Conversely, if the connection breaks because the person walks away out of range of the device you were connected to, we get a callback there as well to say, not connected anymore. So you manage your UI according to that status. And it might look something like this. So I've got an if statement there just saying, well, what is the new state? Am I connected? Am I disconnected? It's easy stuff. Next is about GAT. So discovery and connecting, that was GAP, generic access profile. GAT is about state data. So devices have state data. They know what the state of each of their buttons are. Think about the microbit there. Okay? The way there's some other examples of device state there. The way state data gets exposed so that you can work with it is via an almost database-like structure, very simple hierarchy database. We call it an attribute table internally, but logically it's structured in terms of things called services at the top level, and services group together things called characteristics, which are really state data items. So services are containers for related characteristics. So on the microbit there, for example, there's a thing called the button service, and inside it there are two characteristics, one for each of the two buttons. Characteristics have a type and a value. So in the microbit example that you saw, the value of each of those characteristics would be 0 if they're not pressed, 1 if they've been pressed, 2 if they've been pressed for more than 2 seconds. That's a long press. Okay? So you can see the way state data is modelled. And sitting underneath characteristics, sometimes characteristics have things attached to them called descriptors. And descriptors are mechanisms for giving us metadata, a bit more information about the characteristic, and ways in which we can configure certain behaviours related to our characteristic. I'm really kind of jumping ahead all over my slides here, but what the hell? When I was using the motion detector, the accelerometer, what was happening there was things called notifications, which we'll come on to later, were streaming in from the microbit to my phone. And that was happening because I switched them on by updating a descriptor attached to the accelerometer data characteristic. So it's got a flag attached to it. If I switch it on, I start to get these messages. Switch it off, they stop. So descriptors are for that kind of thing. So characteristics have a type, they have a value, they also have properties. And the properties tell us what we can do with the characteristic. Can I read its value? Can I change its value by writing to it? If I write to it, do I expect or require a response back to confirm or not? And so on. And there's a list of the kinds of operations that are defined by the spec there on the slide. Most commonly used ones are read, write no response, and notify. That's the notification thing that we saw streaming in very rapidly, those motion that motion information. This is freaky. What's going on now? Was that the projector? Okay, so that one's gone. Thank you. Well spotted. I haven't thought to look this way yet, because my laptop's there. Okay, everyone, with me. So those are the kinds of things we can do, and characteristics kind of define what they support. So I mentioned that characteristics have a type. Well, in fact, services, characteristics, and descriptors, they all have a type indicator, and it's a UUID that tells you what type of state data it represents. And there are 16-bit UUIDs, nice and short, that come from the Bluetooth Special Interest Group, my lot. And if you want to create your own, which you can, there are 1 to 8-bit values that you can allocate. So yes, you can create your own custom Bluetooth profiles. Collectively, this stuff is called a profile, the services, characteristics, and descriptors, and you can invent your own. The thing running on the Arduino-based lighting system is a custom profile that I invented, designed it, implemented it in C, C++ on the Arduino, and programmed my phone to understand that profile and communicate with it. Okay. Yeah, that's really confusing me. Look this way, Martin. So discovery is gap, you saw that. We then connect. We've got a state data table, which is hierarchical, services, characteristics, and descriptors. The two devices talk across that connection in a client-server architecture. So typically, and this is not fixed, but typically something like the smartphone will be the client, and the other device will be the server. It doesn't have to be that way around there. And they talk using something called the attribute protocol. For most APIs on most platforms, you don't really need to know any of this stuff. If you're doing some low-level programming on one of those small devices I had with me earlier today, then sometimes you do. The API works at that level. If you work on a smartphone platform, usually the level of abstraction is higher than that. So you're working with higher-level procedures, and behind the scenes, the protocol stuff's going on, and you kind of don't care too much. The only time you see it is with one called notification there, because you will deal directly with notifications because they're so cool. So I'm going to move quickly through the Android stuff. Not surprisingly, Android has classes that represent these ideas. There's a service class, a characteristic class, and a descriptor class. So you'll work with those extensively. You'll do things like create service objects and then find the characteristics it has and then invoke read and write operations on it. You can do things like enumerate services. You can say to a device, hello, what services do you have? And then go, oh yeah, you actually are quite interesting. You know, I learned a bit about you from the advertising discovery phase, but not quite enough to be sure whether I'm interested. But if I connect, I can then find out all the services the device has, and then I've got a very good idea what it is and what it can do. Reading a characteristic value, one of the most common operations, again shown here, Android, but it's really straightforward. The bottom line is that I create a characteristic object which acts as an argument, because I want to say which characteristic it is that I want to read, and then I just make a call to a method called readCharacteristic. Incredibly simple. And as I mentioned earlier on, everything's pretty much all asynchronous, because that call to readCharacteristic did not read the characteristic there and then. It initiated the process of reading that characteristic, and later on, like 3 milliseconds later on, I'll get a call back with the value that's been retrieved from the device, the remote device that we're connected to. Switching on or off notifications. Writing characteristics, same thing. Exactly the same pattern. You say write instead of read, so that's really simple. And in terms of the lighting device there, I actually have one service with 3 characteristics in it. One is called lighting strip control. I'm going to cough, excuse me. Can we mute me? Mute. Yeah? Never mind, sorry about that. I'll just share my coughing with you. Yeah, I've got a dry throat. So lighting device. I don't know Romanian for please mute quickly. I'm going to cough. So lighting device has just got one custom service, 3 characteristics. One's called lighting strip control. It has a byte array as its value, and I write a single octet to say this is what I want you to do, and sometimes there are more octets for parameters. So the initial thing that you saw with this effect, shall I do it again? I'll show you this. That thing. I can select other colours, so I send, I think it's 6 as the command, and an RGB parameter, 3 more bytes to say, and this is the colour I want you to use, okay? So that's writing to characteristic, great way of controlling devices. Oh yes, so notifications, which is what was being used with the accelerometer BBC microbits example, kind of 2-stage process where Android is concerned. Technically, what you're trying to do is tell the device to switch a flag on a descriptor attached to the characteristic whose data you want. Okay, you're trying to say, whatever value is in that characteristic, send it to me whenever it changes or whenever you think I need to know. Sometimes it will be on a timer, sometimes it will be based on changes having occurred. So on Android, you have to do this in 2 stages. There's a local change, when you make some calls, that basically tells the Android runtime system, hey, I'm expecting notification messages relating to this characteristic. Send them to me if you receive any. And the second stage actually sends, using the attribute protocol behind the scenes, a write request to the remote device specifying this particular descriptor and says, switch it on. And once you've done that, you'll potentially immediately start to receive notifications. And as with everything else, those notifications will arrive via a callback to that same object, the callbacks object I mentioned. I have something called onCharacteristic changed, because the notification is saying, I have a new value for this data characteristic. And you say, thank you very much, and you use it in your user interface, in your application in some way. Easy peasy. And that, my friends, brings me to my final slide. Hopefully what you've seen, whilst I started talking about the smart home to give us some context and to find, as an excuse to tell you some things about Bluetooth you may not have already known. They all apply to numerous IoT scenarios, to industrial, to healthcare, all sorts of sizes of building, be it residential home, commercial property, or indeed applications across smart cities. I'm doing a smart cities course at the moment through a British university, and Bluetooth's appearing all over the place in the use cases there. So thank you very much for listening. I hope I'm not behind schedule. No, I'm not. That's fantastic. We have time for questions, I guess. Hi.
Hi. You spoke already about security, and I was curious about the new Bluetooth 5. If it will use an AES 256 encryption key, or just the 128 as earlier?
Yeah.
And how easy it is to hack a Bluetooth device nowadays? Because, as you said, they are used in very important gadgets as heart monitors, and it would be very problematic if someone would hack it easy.
That's two questions. Can't tell you anything about security changes for the next release because I'm not allowed to, so sorry about that. And just to explain that, because I hate it when I say I'm not allowed to answer that question. Being a standards body, we have to get lots of companies who are all competitors working together. So we have to have agreements with lawyers that say this is how it's going to work, we're not going to release this information, otherwise other competitors will have an advantage. So it's not just that I'm difficult. That's the way it works. So I can't answer that one, I'm afraid. How easy is it to hack a Bluetooth device? It depends. Okay, piece of string time. How long is a piece of string? As I said, manufacturers have a toolbox of security capabilities. If they use them all to address all the potential threat scenarios their device has, then they can be FIPS compliant, and the US government will say this is a secure device. And go look at the FIPS spec. It's extremely technical, extremely challenging. Apple HomeKit has remarkably stringent security requirements as well. And HomeKit's about Wi-Fi and Bluetooth these days. Maybe other things in the future, that's what it's about now. So, is it possible to implement a Bluetooth device with no security and then later on think, I wish I'd added some security? Yeah, that can happen. Okay. The microbit's an interesting one because it has quite a lot of the security features built into it. It's part of the work that I did, actually, because I was thinking about the classroom. I was thinking about bullying. So lots of things I was worried about because it's going to be used by kids and so on. So it's got lots of security nailed into it. However, there are use cases coming up where it would be better if there wasn't. There's no need at all. Okay? So it depends on the value of the data and so on. So it can be as secure as you want it to be. But manufacturers have to think about this stuff. We're in the middle. We don't really know we don't understand the businesses of our members and the use of their particular products. So they have to figure that one out. Wait there, though, because I'm sure I'll get lots of questions now. You get a prize for your fantastic question. Hello. Hello, camera. Thanks. Okay, do we have time for another?
Yeah, I have a question.
Hi.
So you're saying that version 5.0 should be released at the end of the year, and one of your slides I could see that you mentioned the CDH encryption key exchange for pairing, which was proposed as a least secure connections in 4.2, but that still is not yet implemented in major BLE chip providers. Mm-hmm. So do you have a mechanism to reach out back to the companies that collaborate on these protocols in order to actually implement them?
Yeah, it's a good question. So the question there is basically saying the specification is a piece of paper, or it's a PDF more usually, 3,000 pages. And of course, specifications have no value unless they get implemented. So in terms of compliance with the specification, we're strict about that, but often features are optional. So pairing, which is the process whereby two devices exchange or derive encryption keys for various purposes and come to trust each other. In the last release of Bluetooth 4.2, made some changes to make that really secure using asymmetric elliptic curve Diffie-Hellman key agreement protocol, to be precise. Your comment is that that's not appeared in many devices yet. The latest Apple devices do implement 4.2. The issue is there's always a lag between the specification being published and then, of course, manufacturers have to understand it. They have to implement the new capabilities in hardware sometimes, more often in firmware, and then it has to fit their product roadmaps. There's always a lag, but that stuff's coming. I'm certain of it. But there'll be a lag again with 5, okay? This is the nature of the beast. On the one hand, things are a little slow sometimes with a very highly standardized technology. On the other hand, you get stuff that works. So you have to decide which of those is most important. You get a prize though, sir. That was such a good question.
You want another question? Or Okay, we can take questions for sure.
Hi.
Hi.
I just wanted to ask you if you could explain a couple of words what exactly is that you have built here, mostly for this do-it-yourself enthusiast who would like to know how can you use these Bluetooth devices for our little project.
Okay.
So what we saw was the Android side, right?
Yeah.
How you use the API on Android. What exactly happens on the other side? You have a Bluetooth device and you have something on the...
Okay. Yeah, I was going to fire up a web page, but I won't. Yeah, great question. So what I have exactly here, in addition to Lego and glue and tape, is an Arduino Uno. It's a couple of years old. It has what's called a Red Bear Labs shield, a Bluetooth Low Energy shield. So if you don't know Arduino, a shield is an adapter card you plug into it. That gives it its Bluetooth interface at a hardware level. And it's running code that I wrote in C++, because that's how you program an Arduino. Okay, so that's how I went about doing that. Now, in terms of, the client side is Android, but it could have been anything. In terms of learning to do things like this and just having a play and explore and experiment, if you go to Bluetooth.com, that's our website, click on developer resources or develop for Bluetooth or whatever it is that it says these days, they keep changing it, you'll find that there are lots of resources there, including something called the Smart Starter Kit. The Smart Starter Kit is an Arduino-based project. You follow the steps, you do the Android coding. It's not that, it's something slightly different, but you build little circuits, really easy stuff. I know nothing about electronics, honestly, and I could do it. But for the smartphone side, you have labs and full source code solutions for Android, Apple, although it's old, it's Objective-C, BlackBerry 10, and Windows Phone. So, lots of stuff there to take a look at. And there are other developer resources as well. So we have one for Gateway, built out of a Raspberry Pi. I mentioned that RESTful API. So it implements at least some of that API just to show you what's involved, and it uses Node.js running on a Raspberry Pi to interact with Bluetooth devices. So Bluetooth.com, that's the place to go. I think you'd like a prize. The good thing here is I'm not selecting the questions, so I can't take any responsibility at all for who I'm selecting for prizes, because I'm not.
Okay.
If anyone feels ignored, blame the organisers, it's not me.
Questions?
Yeah.
My question would be, I understand the need for low energy for wearables, but why in my home would I want Bluetooth? What can Bluetooth do? You mentioned a couple of things, but most of them can be done by wireless either. So, or
Wi-Fi.
Ethernet. Yeah, Wi-Fi.
Yeah.
So, why would I want to start, or this thing? This can be done, controlled by wireless also, so.
Yeah. I've lost something that was in my pocket a second ago. I disagree, first of all. The sensors that I described, collecting all that data that are in my attic, in the walls, under the floor, under the ground in my garden, keeping track of the status of pipes and so on, you can't do that with Wi-Fi. It's too complex, too expensive, and difficult to power. Cost is a real issue. Some of the things that Bluetooth is going to be used for or is used for are very low-cost commodity items to start with, light bulbs. Okay? These are really cost-sensitive devices. Now, you could add Wi-Fi to them, and there are Wi-Fi controllable bulbs out there, I know, because of course they're plugged in, so they have power, so power is not an issue. But the cost of adding a Wi-Fi module and TCP/IP stack to something like a light bulb is significantly more than a Bluetooth one. It's very cheap. Okay? Being cheap is one of the benefits, and for those tiny devices that you need lots of, and that you will buy lots of over your lifetime and so on, it's a real issue for manufacturers. So low power is one of the things that they like, and they like price. They do. It's all about profit margin and being competitive in the marketplace. Would you like a prize? Because that was a very good question. Even though you nearly said you didn't need Bluetooth. Nearly. Take it back. Take it back right now. Okay. Hi.
One question.
Oh, who's next?
We know here.
Oh, you? Okay, right.
We know these days the number of wireless connections and Bluetooth connections are growing up, and should we worry about that, or does this thing affect our health somehow? I don't know.
I'm not sure I understood all the question. Let me just check. I think you asked about the number of connections.
Yeah, number of wireless connections and Bluetooth connections around us in our house, on our hand, on our ear.
Are you asking, is there a limit to the number of connections? Or are you concerned about health?
Yeah, about health.
Health?
Yes.
Okay, so the question seems to be, will using lots of Bluetooth devices fry my internal organs? And the answer to that question is no, it will not. Now, I don't know a huge amount about this, but actually a few weeks ago I read some stuff about testing procedures, I think in the United States regulatory body, for like how they ensure that devices are safe to use. Because radio is electromagnetic radiation. It has the ability to agitate molecules so they have more energy, so that they get hotter, okay? This is how microwave ovens work. Microwave ovens work in the same frequency range as Wi-Fi and Bluetooth, and cordless phones. It's called the ISM spectrum, industrial, scientific and medical. It's very popular because it's free of charge. So will Bluetooth cause me to fry like bacon? No, it won't, because the power is so low. This is what they do something weird like, I think the origins were that they observed lab rats, and when they got to a level of kind of radiation where the rat's behaviour started to change, they said, okay, that doesn't look good, and they divided that value by 1,000 and said, right, that's the upper limit. So they were very safe. But that's all I know about that subject, just some stuff I read a few weeks ago. So I think you're okay, don't worry. Let me give you a Bluetooth device. Don't be afraid. You can even switch it on. Okay, are we okay for time? Yeah.
I was wondering, you were saying that the range is to quadruple in the next release.
Yes.
Are you moving to a lower frequency band to achieve this, or is there other...
Not to achieve that, no. To achieve the longer range without affecting power, we're basically going to offer a choice of, do you know what modulation schemes are? Okay, so there will be a different modulation scheme to achieve the longer range, which is all about, it's about making the receiver more sensitive so that we can get nearer to the threshold of noise and still extract information safely from it. This is radio communication now. Okay, so it's about using analog symbols to allow us to mathematically detect and correct errors in communications. Fundamental datacom stuff. So that's how that's being achieved. So we're not increasing the transmission power to achieve that because we don't want to use more power. It won't be low energy much longer if we kept doing that. So that's how that works. And this is the last one, people. It's a nice bag, though. I'll give the bag away, maybe. There you go. Thanks. Good question.
I have another question.
Where did that come from? Oh, right.
With regards of Bluetooth 5 and Discovery, you said earlier about the network mesh that will help to, firstly, to save energy. My question is, will I be able to make discovery of nearby devices with the help of neighbors? So like, I found the nearest and later on I go to others and it will help me.
Yeah.
But it's for the neighbors?
Right. So, yeah, this is going to be a very bad answer to a good question here. Bad answer for two reasons. One is I don't know the answer. So that's a good reason for, okay. And the other is I'm kind of not allowed to say anyway, even if I did know. We're at a stage in the specification process where we're allowed to sort of talk about the fact that it's coming. I'm not allowed to say anything about how it works. And it so happens I'm way behind on my reading anyway. So I actually don't know how discovery within the context of mesh works. There is something similar to it. It's very, very different. There are a whole new set of concepts in mesh networking that are completely different to the kinds of things you might know about from working with the current Bluetooth generation, which is very much a hub-spoke network topology with one central device and small peripheral devices dotted around the edges. It's very, very different. So things like adding a new device to your mesh network, there's a procedure for that, but I don't know the detail, and I'd probably get fired if I told you anyway. So, thank you. Sorry, no more prizes though. Good question. Down here? Okay.
In the beginning you mentioned that Bluetooth sensors can draw power from the environment.
Yeah.
Is it something that they are already available for home products? And that's one question, and I don't know, maybe related with it, it's something that that power can be drawn also from the devices that requesting the information from the that sensor? Okay, I'll try and answer those. First of all, the ability to generate power from the environment, that has nothing to do with Bluetooth, just to be clear about that. That's, again, the banner heading is energy harvesting. So that's an area of technology that's progressing, that's of interest to us because of the ways we see sensors being deployed and so on. Are there commercial products that use Bluetooth and use energy harvesting on the market? Yes, there are. I've got some Bluetooth beacons at home that use ambient light, even indoors, to generate power. Generates enough power for the... Who knows what Bluetooth beacons are? Some of you, okay, so a Bluetooth beacon, it's a small device. This thing in my pocket can be a Bluetooth beacon, it can do other things as well. And they just use the advertising thing we learnt about, which is normally to do with discovery, but sometimes devices only advertise and they don't care about being connected to. You never connect to them. There's enough information in the advertising packets to serve a purpose. So you've probably heard of iBeacon, because that's Apple's implementation of Bluetooth beacon technology. And Google have something called Eddystone, which is another implementation of Bluetooth beacon technology. But in both cases, the advertising packets contain a small amount of information that an application can derive meaning from. In the case of iBeacon, it's just a code, and the code maps to a physical location. So if you're walking along with an application installed from some department store that's all over Romania, and it receives a beacon message that it recognises, it can look at that code, do a cross-reference to a database and say, aha, you're in Cluj in the sporting goods department of the store on this street. When you're indoors, don't need GPS. It's great for indoor location positioning. That's what beacons are for. I've almost forgotten how I go on to that, to be perfectly honest. So yeah, I've got Bluetooth beacons that can work with ambient light. So you can deploy your beacons, don't have to worry about powering them, having someone to change the batteries in 10,000 beacons across the country. Not a problem if you're using ambient light, for example.
So I think we are good with the questions, and yeah.
I've enjoyed myself.
Thank you very much, Martin.
You're welcome. Thank you.
It was great.